All right, so we're doing some money stuff. Finance is the name of the unit. Last week we did simple interest and we touched on compound interest. Let's just recap what we've done in this unit thus far. And it's not that bad. If you know the formula, it's whatever. So simple interest, and we're gonna contrast this with compound interest. So the formula for the final amount is A equals P 1 plus RT. You can also write this as P plus PRT. R is the interest rate, P is the principal, T is the time. The interest here is simply this component. The interest is PRT. This is the interest per year. And that is it going to be the same or is it going to change the interest for simple?
It's not going to change.
It's not going to change. It's going to be a constant. You can model this using a linear equation where your principal is your y-intercept. On the x-axis, you have time. On the y-axis, you have your amount. Principal is your y-intercept. And then what are we adding to this? We're adding PRT. So that's going to be your slope. So to go from here to here, you just add PRT. To go from here to here, you just add PRT. So it's a linear function. On the other hand, we have amount that is equals. Now this is no longer linear, it's exponential. We get P 1 plus I times, no, that's not right. It's 1 plus I to the power of n, like that. You can't open this bracket, by the way, because there's an n here. This bracket you cannot open. The interest here is a little bit complicated. The interest is, it's always amount minus the principal. Interest here is also amount minus the principal, but the formula here is a little bit weird. Amount is P 1 plus I to the power of n. Principal by itself is just P. What you do here is that you take a P common. You pull out a P from the two expressions. If you pull out a P from the first expression, you're left with 1 plus I to the power of n. If you pull out a P from this, what are you left with?
-1.
Yeah, like that. And that's the expression for your interest I. And this is always going to change. It's never constant. Graphically, a compound interest, again, you have a P here, but instead of it being linear, it's going to increase like this. And you have N here, and you have A on the y-axis. P is your y-intercept, just like it was before. Furthermore, compound interest gets a little bit dicey because the interest and N, they're going to change depending on the compounding period. If you do annually or per annum, it means once a year. Nothing changes, right? So no change. No change for both of these guys if it's done annually. But let's say it's done semi-annually. How many times a year is that?
Twice.
Twice. So for the interest, you always divide the interest. You always divide the interest by that, and you always multiply n, which is the compounding periods, by 2. Well, by whatever this amount is. So semi-annually, it'll be 2. Quarterly, it'll be 4. What do you think monthly will be? How many months in a year?
12.
So like that, yeah?
Mm-hmm.
You also have weekly. Um, how many weeks in a year? It's 52. What else can they do? They can ask you for bi-weekly as well. Bi-weekly means every 2 weeks. So if we have 52 weeks, that means we have 26 bi-weeks. And that's what you do. And then you want to plug it into the appropriate formula for compound interest. Another way to denote this expression right here, that A there stands for future value. It's the amount in the future. A, you can also replace that with future value, because that's the amount that your principal becomes in the future. Now you can get an expression for present value as well. Present value means the P here, present value. How do we solve this expression for P? You want to divide both sides, right? This is what we have. A equals P1 plus I to the power of N. The goal is to solve for P. Let's say they give you an amount and you want to solve for P. You divide both sides by this bracket. It becomes A over 1 plus I to the power of N. And we know exponents. We can move this to the same level. What happens to the N if we move it up into the numerator?
It becomes negative.
Becomes negative. So the expression for present value, PV, is the amount today, is the principal amount today. That is going to be A times 1 plus I to the power of negative N. So this is the formula you want to use. If they give you a future amount, they ask you for the money today. And this is the expression, or this one, they're the same. You want to use if they ask you for what your money will be in the future. The only difference is this N becomes a negative. These things, they apply to both cases. Future value, present value, the rules will apply. So you're going to do the divide and times. Let's look at an example. And the goal is to identify whether it's it's the word compound, so it's not simple interest. Most of them are going to be compound interests. And the goal is to identify whether the question's asking us for the present value or is it asking us for the future value. So Anton's parents would like to put some money away so that he will have 15,000. He'll have 15,000, not today, but 10 years from now, he wants 15,000. They can earn 6% per annum compounded annually on their investments. So I guess the goal is to find out this amount. Is this a present value question or is this a future value question? What's the unknown, PV or FV? So this is the amount in the future. It's already given. We're trying to find PV. What's the amount today that we need to put in such that in 10 years that will compound to 15,000? So here your unknown is what's the amount today, PV. You're given the amount, 15,000. This is 10 years from now. Your N is 10 times 1 because it's compounded annually. It doesn't really change. And your interest rate is 0.06 divided by 1, which is still 0.06. So our formula for present value, the money today is A 1 plus I to the power of negative N. Now you just plug everything in. 15,000, 1 plus 0.06 to the power of negative 10. So first you want to plug what's 1.06 to the power of negative 10 and then multiply that by 15,000. Are we expecting this number to be higher or lower than 15,000?
Lower.
Yeah, because you're essentially dividing by this thing with a positive exponent. So the amount that you need to put in today is 8375.92. So this amount in 10 years will almost double. It will become 15,000. And that's it. So that's how you want to solve a present value question. But the important part is to identify that it's a present value question to begin with. Sometimes you have to sketch like a timeline if there's a lot of information. All right, so Monica wants to borrow some money. Her bank will charge her 6.4% interest compounded quarterly. She wants to repay the loan in 5 years, but doesn't want the amount she pays back to more than $20,000. So we're here today. In 5 years, she wants to pay back an amount not more than 20,000. What is the maximum amount she can borrow today, right? Because this is 5 years later. What's the amount that she can borrow and how much interest does she pay if she doesn't pay back anything until the end of 5 years? All right, so what is the unknown here? PV or FV?
PV.
Yeah, the unknown is PV. It's the exact same question as last time. The only difference now is that it's being compounded quarterly. So PV is equals to the amount or future value, 1 plus I to the power of n. PV is, sorry, negative n. Right? Yeah, negative n. What do we know? I is 0.064. It's been compounded quarterly. What do we divide this by?
4.
4. That's the number of compounding periods per year. It's denoted by M. N would be 5 times 4, so that's 20, and that's 16. So our amount is 20,000. 1 plus 0.016 to the power of negative n. Plug that in, you have the answer for the present value. 1 plus 0.016 to the power of negative 20. It is 14,559.81. So that's the amount that she can borrow, maximum amount that she can borrow. The next question is, how much interest does she pay over the period of 5 years? How do we find the interest? What you do is you can just use the definition of interest. It's the wrong letter. Interest is always the amount minus the principal. Your future value minus present value essentially is what it is. We have both of these numbers, we just plug it in. Amount is 20,000. She borrowed 14,559.81. So the money that she puts in, I think is this. 20,000 minus 14,559.81. Yep. And that's the interest. So that's a lot of money over the period of 5 years. You end up paying $1,000 in interest per year. Is it worth it? So that's the difference between risk and reward. So if your business nets you a net profit, which most businesses do, if it nets you a net profit, profit is what is it? It's revenue minus cost. So the amount that you make from your business, revenue, cost is the amount that it takes to run the business. And that is your profit. If your profit is greater than or equal to your interest, then you're good. If that's not the case, then you are screwed big time. So at this point, you're losing money on both ends. But that's the thing with businesses. You don't always start making money from day one. You might lose money for a long time, and then finally you start making money. I'm still not sure if Uber is profitable or not. Because initially they just took over the market because they were relying on this principle. They didn't want to make a lot of profit. Well, they essentially couldn't. That's how they took over the market. Their prices were way lower than normal cabs. Another example is Airbnb. Same idea. Their prices were way lower than normal hotels. So they took over the market for a few years, and after that, they rose their prices, and after that, eventually, they started making profit. I know Airbnb is profitable. I'm not sure about Uber. So there you go. We got Tony investing 5,000 that he would like to grow to at least 50,000 in 40 years' time. What's the interest rate compounded annually that will provide this? All right, what's the missing component here? What's the unknown?
The interest rate.
So our I is unknown. We know our N. We know our present value or our principal amount, that's 5,000. And we know our future value or the amount in 40 years' time, that's 50,000. We're missing I. So either formula would work here. I'm just going to use the basic formula, which is this. Principal, sorry, which one would be easier? Amount is principal 1 plus I to the power of n. You can use that or you can use this. It doesn't really matter. I'm going to use this because I don't want to deal with negative exponents. It will save us a step. So let's plug things in. So it's being done compounded annually, so we don't have to worry about dividing, multiplying. The final amount is 50,000. P is 5,000. Interest rate is unknown, but N is 40. There we go. How do we solve this equation? What will be the first step? Our unknown is here.
You divide by 5,000.
All right, so that will give us 10. 10 equals 1 plus I to the power of 40. What's the next step? I'll give you a hint. Do you want to get rid of that 40 first and then subtract 1? How do we get rid of that 40?
You do root of 40.
Yeah, you do the 40th root of 10. On a calculator, the way you do this is you do 10 to the power of 1 divided by 40. That's one way of doing it. Another way is you use shift plus second function on the square root, which will give you this square root function. And you want to press 40 that 10. That's another way of doing this. I like this way. Because it's not all calculator have the x square root. So 10 to the power of 1 divided by 40. Which gives me 1.05925 equals 1 plus I. Now you just subtract 1. So your I is 0.059 or 5.9%. And that's the final answer, 5.925% if you want. So and that's it for this question. So that's how you want to do it when the interest rate is missing. You have to do the x root. Does this make sense?
Mm-hmm.
We're just using these formulas. Let's do a complicated question, because this one will force you to think a little bit. Everything else is just plug and chug for the most part. So Colin borrowed some money. 3 years later, he paid 5,000 towards the principal and the interest. All right, so this is one of those questions where you have to kind of sketch the timeline because there's multiple things going on here. So this is time 0. At this point, he borrowed some money. We don't know what it is. We're going to call that X, or you can call that P. We don't know how much money he borrowed. 3 years later, at this point, he paid 5,000. So it's like, here you go. You can have 5,000 to the bank. After another 2 years, so here, he paid another 5,000. And then another 5 years later, let me actually do this different color. After how many years? 5 years. 5 years later, he paid another 5,000. And this completely cleared off his debt, basically, including principal and interest. Now the question is, how much money did he borrow initially? All right, cool. So let's do this. The initial amount is P. What we need to do is we need to find the amount here, the amount here, and the amount here in terms of P. Once we have that, we're going to subtract 5,000. And eventually, once we subtract this 5,000, we will get the original amount. So let's see how that works. I'm going to call this 1, 2, 3. Let's focus on 1. What is the amount right there? How do we find the future value right there? Using this. So your future value, or your amount, at time 1 is principal 1 plus I to the power of n. It's been compounded quarterly. So what do we do with the interest rate?
You divide by 4.
So 0.0716 over 4. 0.0179. What do we do with the n value? We multiply it by 4. So 3 times 4 is 12. So at this point, his amount that he owes at that point is 1.237 times the initial amount P. So at time 1, this is what he owes. Yeah?
Mm-hmm.
But then at time 1, he paid off 5,000 from this amount. He didn't pay off the whole thing. He only paid 5,000. So what we do here is that the amount that he owes now at time 1, you subtract 5,000 from this. And this essentially becomes your principal going forward. So now we can erase this completely. So at time 1, the money that he owes right now, yeah,
Mm-hmm.
is 1.237 P minus 5,000, where P was the initial money. So this is his principal. Now we do the exact same thing here. We do the exact same thing here. So at time 2, his amount will become the principal amount, 1.237p minus 5,000 times 1 plus I to the power of n. 2 years, so that'll be 2 times 4, 8, like that. And again, at this point, he pays off 5,000, right? Like that. So this is going to be the amount that he owes. So let me just simplify this a little bit. So this will become 1.237 p times 1 plus 0.179 to the power of 8. So this becomes 1.4256 p minus 5,000 times 1.0179 to the power of 8. So when I open this bracket, I get this number. And then I subtract 5,000 from it. So at that point, our principal is going to be 10762.50. And then we do this one last time. So this is essentially the money that we owe over here. We're gonna find its future value. So at 3, we know that it's gonna be the exact same thing, except now it'll be, this is your principal amount. 1.42568 minus 10762.50 times this amount. And you subtract this. Yeah, like that. He pays this off. How much does he owe once he pays this off at the end of here? How much money does he owe? Nothing, right? Because it says he pays off the whole thing. So at time 3, he's gonna pay off the whole thing. So the way you solve for this p is that you set this entire expression equals to 0, like that. So it's a little bit complicated, this one, because the principal keeps changing from one point to the other. Again, I'm going to open this bracket. So 1.42568 times 1.0179 to the power of 8, 1.643096p minus 10762.50 times that to the power of 8 minus 5,000. 10762.5 times 1.0179 to the power of 8. Okay, yeah. So this is what we get. Equal to 0. We want to solve this for p. This over 1 point dot divided by 1.42568 times 1.0179 to the power of 8. So this over this gives you a final principal amount of 10592.06. And there we go. That's the final answer to this question. So this one was complicated for sure because it was a 3-parter. The principal changed from one point of time to the other. So the thing you do is that you find your amount at that time, and that becomes your principal, and you carry that forward from one point to the next. So his initial money was 10,592.06. Does this kind of make sense? This was definitely complicated. Let's try this one. This one's again similar, but it's slightly easier because instead of subtracting 5,000, we have our final investment. So again, who's this? Sally. At time 0, she borrowed some money, or she invested some money, sorry. She invested some money, P, at 6% for 5 years. So at this point, it was 6% per annum for 5 years. At this point, this is going to be our time one. After 5 years, she took the money that it accumulated to, and then she invested it for 6 more years. But now it's at 7.2% quarterly. And at the end of all these 11 years, her final amount was 14,784.56. So this is the amount right here at the end of the 11 years, 5 plus 6. The question is, how much did she invest initially? So our present value is missing, yeah?
Mhm.
How do you think we approach this? It's very similar to the last question. What we do is we find, step one, we find the amount here at the end of period one, the final amount from this principal at the end of period one. And then we treat this amount as our principal, and this essentially becomes time 0. And then we carry this forward for 6 more years. So that's our goal. Step one, we find the amount at the end of the 5-year period. So A is P1 plus I to the power of n. Now I is it's been compounded annually, so we're gonna have to change these. Principal, we don't know. This is the unknown. What is I here?
0.06.
And n, we again don't have to touch this. That's 5. So this becomes P times 1.06 to the power of 5, yeah? This is the amount right here. So the amount right there is P times 1.06 to the power of 5. This is the final money. But what she did was she took this amount and then she invested it for a further 6 years. So this right here will be our new principal. Now we're gonna reinvest it for 6 more years. So now we're right here. We need to go from here to here. It's been done and quarterly, sorry. So your interest rate will be 0.072 divided by 4. And your n will be 6 times 424. Like that. 0.072 divided by 4. Yeah. What is our final amount? How much did it accumulate to?
14,780.
So at the end of this period, our final amount will be 14,784.56. Our principal amount at this point was P times 1.06 to the power of 5. Now it's going to be 1 plus 0.018 to the power of 24. So again, your principal is this. That was the final amount right here. And this is the new coefficient that you multiply with to get the amount after 6 more years. How do we solve this for P?
You divide by 1 plus 0.018 to the power of 24.
Yeah, so you divide by both of those. So 14,784.56 divided by, you just divide by this, divide by this.
Mm-hmm.
So it'll be divided by 1.06 to the power of 5. Whatever answer I get, I need to divide that by 1.018 to the power of 24. So that gives me a final principal amount of $7,200. And there we go. So you definitely have to sketch it if there's multiple events like these, okay? Whereas Luis is investing 5,000. So that's your present value or your principal. Interest is 0.054 semi-annually. Divide that by 2. Time, we don't know what it is. Well, we need to multiply that by 2 as well. And we know the amount is 12,000. So principal is equals to, which formula should we use? I'm going to use this one. Amount is equals to principal 1 plus I to the power of n. So amount is 12,000. Principal is 5,000. I is 0.027 to the power of n. How do we solve this equation for n?
You divide by 5,000.
Yeah. So that gives you 2.4. And then
You do logs.
you do logs. So log of 1.027 to the power of n is equals to log of 2.4. Sometimes you'll see this being done as ln of 2.4 equals ln of 1.027. Both of these will give you the exact same answer. What's the difference between log and ln? Do you remember?
No.
Ln is the natural log. It's called a natural logarithm. A log, square root has an invisible index of 2. Indices, we did this last time. Log has an invisible base of 10. In fact, the function y equals to log of x looks like this. Does not cross the y-axis. There's an asymptote there. It's the inverse. Log x is the inverse function of the exponential function 10 to the power of x. Y equals 10 to the power of x. Log of x is the inverse function. Remember, inverse is just something that you reflect on this line, y equals to x line. Ln of x, on the other hand, looks very similar to log of x. Looks like this. They both go through 1 here. The difference is that ln of x is the inverse of e to the power of x, where e is the natural number. E is a constant. It's like 2.71 something. Like how pi is 3.14159, whatever. E is the natural number, okay? And ln of x is the inverse of e to the power of x as a function. It's called a natural log. You can use both of these. They will give you the same answer. We're going to stick with logs. Lns you want to use if you have e. Anytime you see e, you want to use lns.
Mhm.
We use it in population models in real life. We use it for a lot of things, but let's stick with log for now. So here n will simply be log of this divided by log of this. Log of 2.4 divided by log of 1.027. That gives you a long time, 32. Sorry, I messed something up here. N was supposed to be 2n. 2, 2, 2, 2. So whatever answer I get, I need to divide that by 2. So n is actually 16.43 years. So it's going to take 16.43 years for this to occur, which is a long time. You're getting 2.4 in 16 years. I don't think that's worth. Anyways, this is a safe thing. That's still a decent amount though, 5.4%. Usually if you put it into some sort of an investment, you are unable to take it out as you want. If you want to take it out earlier, then it matures, then you have to end up paying the bank money. this looks like it could be from a simple savings account. So that's the risk versus reward. So in a normal savings account, you'll get like what? I don't know, like 2% to maybe 4%. There's something called high interest savings account. Maybe these will go 5%. These you can take your money out anytime. You're the boss. But in most investments, and again, these you can even lose money. You can start maybe from negative 5% to maybe, I don't know, 30%. You can even lose money. You can get a lot though. That's the risk versus reward. High risk, high reward. This, you cannot take it out anytime in most cases. Cannot take out. And usually this is done for a period of 3 years, 5 years, it depends. You cannot take it out. If you do want to take it out, let's say you have an emergency or something, then you have to pay the bank back the money that they would have paid you in order to take your own money out. So that's the risk element. Is this making sense? Is it difficult?
No.
All right, so here what's going on. Sarah buys, so at time 0, she bought washer and dryer for this. At the same time, she only paid 500 for it. And whatever was left over, she borrowed that amount. A year and a half later, whatever was left, whatever she borrowed, which is going to be this minus this, whatever she borrowed, it amounted to 2112, and she paid it off. Now the question is, what's the annual interest rate compounded semi-annually? So our interest rate is missing, but we know it's going to be divided by 2, right? Because it's being done semi-annually. So we don't know what it is, but we know that it gets divided by 2. So I'm going to write that as 0.05 I. What's our n value here?
It's 2.
So it'll be 1.5. That's your time times 2, yeah?
Mm-hmm.
Your m is 2. So your n is going to be your time times 2. So it's going to be 3. How much did she borrow?
2100 minus 500.
Well, that's the cost of it, but when she was buying it, she paid $500.
So you subtract that?
Yeah, you subtract that. So she actually ended up borrowing only $1,612. This minus 5. So your principal amount is 1 plus, let me just write the formula. So your principal amount is 1612. After 1.5 years, it was 2112. We don't know what I is, but we know it's 0.05, 0.5 I. I made a mistake here. It's not 0.05 I, it's 0.5 I. You're simply dividing it by 2. You're halving it. So it'll be 1 plus 0.5 I to the power of 3, like that. I messed up the formula here. It's the other way around. If you want to do it this way, then you need to put a negative sign here. Yeah, that's the formula for present value or interest. The one I was thinking about is this. This one doesn't have the negative value. Both of them will give you the same answer. It doesn't matter. You need to put a negative sign on one of them, which is when you're trying to find the present value P. All right, let's try using this. So step one, you divide both sides by 2112. So 1612 divided by 2112. So that will be 0.7633. This is going to be equals to 1 plus 0.5i to the power of -3. How do we solve this equation for I? You have a negative exponent. This is why I wanted to use that earlier, but you can do it this way as well. Look at this. When you have a negative exponent, what you do is you throw it in the denominator
Mm-hmm.
like that. And then you want to swap positions. This will go here and this will come down there. You're essentially multiplying both sides by the denominator and dividing both sides by the numerator. That's what you're doing, which swaps position like that. Let me plug this in. Whatever I get from that, I'm going to cube root it. So 1 divided by 0.7633. Cube root just means to the power of 1/3. So I get this. Subtract 1. Divide by 0.5. So your interest rate is 0.18846. So that's 18.84% compounded semi-annually. And you are done with this question. So this one I was missing. This wasn't really a sketch the problem, but this always helps. Drawing the timeline always helps, but we didn't have to do a multipart. Did this make sense? Hopefully it did.
It did.
So Iris borrowed some money. We don't know how much, but we do know it's being done semi-annually. The question is, what's the interest rate? And how much did she borrow? All right. So A is equals to P1 plus I to the power of N. Here I is 0.5i, and here your N is 2N because it's been done semi-annually. Let's focus on this. Actually, we can't focus on that. Part A is asking us for the interest. Let's start here. The amount there is 8715.91, right? Principal, we don't know. I, we don't know. But we know it's going to be 0.5i. What's the N value here at this time? How many 6 months in a year? So your N is 0.5. Half a year. Here your N would be 1. But then you need to multiply that by A2 because it's been done semi-annually. So at this point, N, half a year has passed, but you need to multiply that by 2. So 0.5 times 2 is a 1. Yeah?
Mm-hmm.
So that's our first expression. I'm going to do the same thing for down here. You have 9125.56 equals to what? What goes on the right side of this equation?
P times 1 plus 0.5i to the power of 2.
To the power of 2, exactly. Now we have two unknowns, P's and I's. If you have two unknowns, you need a minimum of 2 equations, which we do have. We have the top equation, we have the bottom equation. Now here's the trickiest thing. what do you do with these equations to kill one of the variables? So we want to either kill P or we want to kill I. And this is a little bit more complicated because this is neither substitution nor elimination. What do you think we do? I'll give you a hint. You need to kill the P's. What do you do? What's the, okay, you have four options. Add, subtract, multiply, divide. I'll give you a hint. It's P that you need to kill off. Which one of these order of operations will kill the P? If you take one equation and the other. Adding them, you're going to get 2P, probably, right?
Mhm.
Subtraction doesn't help either. I'll tell you. It's you divide. What you do is you do equation 2 divided by equation 1. Check this out. It's going to look like this. 9125.56 divided by 8715.91. P times 1 plus 5 like this over P 1 plus 0.5i. P's cancels. This is A. You can treat this as A squared. You have A squared over A. The squared cancels out with the A, right? A squared over A is A. This cancels out with the same idea here. So now look at this. It's pretty simple. You just subtract 1 and divide by 0.5 and you will get the interest rate. 9125.56 divided by 8715.91. Subtract 1, divide by 0.5. So the interest rate is 0.094. So that's your I. I can plug this right here. We don't really need anything else. So this becomes 8715.91 equals P 1 plus 0.5 times 0.094. It's to the power of 1. I can just divide both sides by this bracket. That'll give us the principal amount. So 8715.91 divided by 1 plus 0.5 times answer gives me the initial amount as 8324.65. And that's the final answer for this question. That's the principal, that's the interest. Sometimes you have to divide equations to kill the unknowns, as we did here. Usually applies to exponential functions. For linear
Mhm.
functions, simple interest, you would just subtract them, but exponential functions, you want to divide them, like we did for some geometric series questions. All right, let's call it there for today.
Also, I won't be able to have class tomorrow because I have a field trip.
Sure, no worries.
Okay, thank you.
Bye-bye.
Bye.